Now next topic, distance between two skew lines. Equations are vector R is vector A1 plus lambda times vector B1. Lambda is any real, and equation of second line is vector R is equal to vector A2 plus mu times lambda vector B2. Mu belongs to R. These are two skew lines and we want distance between skew lines. Now skew lines means lines which do not lie in the same plane. As for example, if I draw here two lines, then this line L and line M both lie in the plane of this green board. They lie in the same plane. So these are lines, coplanar lines. They are not skew lines. If I draw, suppose this line is L, and if I take another line exactly parallel to this line, say this is line L showing by this pen, line L and line M. I have taken both lines in contact of each other. Now see, this second line, second pane I am removing from this surface in such a way that it remains parallel to this blue pen. So blue pen and red pen, they are parallel, and hence there exists a plane containing these two lines. Here there exists a plane which contains these two lines. So these are coplanar lines. They are not skew lines. Anywhere if you set two pen in the space, consider these two lines in the space. These are parallel. They have same direction. Suppose these are vectors which are having same direction. So same directed lines have same direction. Anywhere in the space, if lines have same direction, then here there exists a plane containing both lines. So these are parallel lines or coplanar lines. They lie in the plane, same plane, so parallel. If lines are in the same plane, then there are two possibilities. Either they are intersecting. If not intersecting, then distinct and parallel, like this. So two possibilities for coplanar lines, either they are parallel or intersecting. But if lines do not lie in the same plane, then they are skew lines. Say here, these are coplanar lines, which you can see this picture in blackboard, this green board. These are coplanar lines. But if suppose this line which I show by this blue pen, say blue pen represents line L and red pen represents line M. Now I am taking off this blue pen from the surface of this green board. See, I am taking off without changing direction. Now see what happens. These lines are neither a parallel nor coplanar. They do not lie in the same plane. So these lines in this way, so these lines are skew lines. There is a distance between them. Here there exists a distance. They are not parallel. If they do not lie in the same plane, not parallel, that means may be like this. So these are skew lines. If keep them in contact of each other, they are not skew lines. If intersecting, then coplanar. But if not intersecting and having different direction, then skew lines. So now we are talking about distance between skew lines, and here formula is distance between skew lines. Result is distance between two skew lines is distance d is equal to modulus of, now say in the numerator I show dot product of vector b1 and b2. Say this is cross product, and dot vector a2 minus vector a1. You can also put here a1 minus a2. If you keep a1 minus a2 or a2 minus a1, final answer will be same because of this modulus. Now in the denominator we keep magnitude of vector b1 cross vector b2. This is magnitude of vector. Here a dot product of these two vectors. So by this formula we can calculate distance between skew lines. If this is L and another skew line is like this M, which I shown by two pens in different direction, not in contact of each other. So there exists a distance between them, and this distance, this is a perpendicular distance. There exists a shortest line segment such that length of this shortest line segment, it is perpendicular to both. It is said to be shortest distance. On both the lines there exists a point such that joining these points, this is a perpendicular to both, it is shortest distance. So this is the formula. Now to understand this method, to apply this method, we are taking question. Find the shortest distance between the lines. These are given lines. Application of this formula. Now see, compare with this result. See, first equation is vector r is equal to, take this as a1. Here vector a1 is I plus 2j plus k. b1 is, this is b1, I minus j plus k. Second line is, compare with this result, vector r is a2 plus mu b2. So this is vector a2. a2 is 2i minus j minus k. b2 is 2i plus j plus 2k. So a1 plus lambda times vector b1, vector a2 plus mu times vector b2. So a1 a2, b1 b2. Now look here. Here you can see that these vectors are vectors showing the direction of lines. And if you check a ratio of these scalar components, see here it is 1 by 2. Here ratio of scalar components minus 1. Here 1 by 2. Ratio of scalar components of direction showing vectors is not same. So these are not parallel lines. They are skew lines. So to find a distance between them, we will apply this formula. Now terms required to put in this formula is b1 cross b2. Now first of all we find vector b1 cross vector b2. So vector b1 cross b2, that is I j k. b1, that is 1 minus 1 1. b2 2 1 2. we keep scalar components 1 minus 1 1, 2 1 2. So that is equal to I into minus 2 minus 1, that is minus 3i, minus j into 2 minus 2, 2 minus 2, that is 0, plus k into 1 minus minus 2, that is plus 2. So 1 plus 2 is 3. So this is B1 cross B2. Now A2 minus A1. So we also require its magnitude. So its magnitude is B1 cross B2, magnitude is square root of minus 3 square is 9, 0 square is 0, 3 square is 9. So this is square root of 18. Then we require A2 minus A1 and vector A2 minus vector A1. Vector A2 minus A1. So 2 minus 1. So 1 times I. Minus 1 minus 2. That is minus 3 times J. Minus 1 minus 1. That is minus 2 times K. So this is A2 minus A1. Now we keep values in this formula. So required distance is required shortest distance D is equal to modulus of B1 cross B2 dot vector A2 minus A1 upon magnitude of B1 cross B2. So that is, this vector is minus 3i minus 0j plus 3k dot A2 minus A1 is I minus 3j minus 2k upon magnitude of B1 cross B2, that is root AD. So modulus of minus 3 into 1 is minus 3, 0 into anything is 0, 3 into minus 2 is minus 6 upon root 18, that is 3 root 2, that is modulus of minus 9 upon 3 root 2. So this is 3 by root 2. Modulus of negative is positive. So 3 root 2, or if we rationalize denominator, this can be expressed as 3 by 2 root 2. This is required shortest distance. Next question. Find the shortest distance between the lines. Say here equations are given in Cartesian form. So from Cartesian form directly we can take vectors which are required to substitute in formula. See from first equation, vector A1. Vector A1 is, say before taking vectors A1, A2, B1, B2, always check that coefficient of x, y and z in symmetric form must be 1, 1, 1. Say here it is 1x, 1y, 1z. So allowed. Take vector A1. That means position vector of point which lie on that line. So say here this is plus 1. So take minus 1 times I. This is plus 1 minus 1 times j. Plus 1. So minus 1 times k. From second equation, A2 is, say we are comparing with x minus x1 upon A equal to y minus y1 upon B equal to z minus z1 upon C. So here x1 is 3. So 3i, y1 is 5, 5j, z1 is 7, 7k. Here also this is compared with x minus x1, y minus y1, z minus z1. So this is value of minus x1. Minus x1 is plus 1. So x1 is minus 1. So if here plus sign is given, put minus. Plus given, put minus. And if minus given, put plus. Vector B1. B1 is 7i minus 6j plus 1k. Vector B2, that is a direction of second line, a vector parallel to second line. So 1i minus 2j plus 1k. Now method is ditto. But before starting method, check here. Say 7 by 1 minus 6 by minus 2. This ratio is 3, this ratio is 7. Ratio of scalar components of vectors which are parallel to given line are not same. Here ratios are not same. 7 upon 1 is not equal to minus 6 upon minus 2, not equal to 1 upon 1. So these are not parallel lines. So we apply method for skew lines. So to substitute values, we find B1 cross B2. So B1 cross B2 is I, J, K, then 7 minus 6, 1, 1 minus 2, 1. That is I into minus 6 plus 2, that is minus 4i, minus 6 plus 2 minus 4i, minus j into 7 minus 1, 6, plus k into minus 14 plus 6, minus 14 plus 6, that is minus 8, minus 14 plus 6, minus 8. So this is vector B1 cross B2. We also require its magnitude. B1 cross B2, its magnitude is equal to square root of 16 plus 36 plus 64 minus 4 square plus minus 6 square plus minus 8 square, that is, this is square root of, it will be 116, this is 116. So that is it is 29 into 4, so 29 root 2. Sorry, I did mistake. 29 into 4, that is 2 root 29. Sorry, it is 2 square root of 29. Now we also require a2 minus a1, vector a2 minus vector a1. So a2 minus a1, so 3 minus minus 1, that is 4. 5 minus minus 1, that is 6j. 7 minus minus 1, that is 8k. This is a2 minus a1. Instead of a2 minus a1, you can also take a1 minus a2. Now putting in formula, required shortest distance D is modulus of B1 cross B2, vector B1 cross vector B2 dot, say this dot must be clear, visible, into vector A2 minus A1 upon magnitude of B1 cross B2. So that is equal to modulus of B1 cross B2, that is minus 4i minus 6j minus 8k dot A2 minus A1, 4i plus 6j plus 8k upon magnitude of B1 cross B2, that is 2 square root of 29. So that is equal to modulus of, this will be minus 16 dot product, minus 6 into plus 6, that is minus 36, minus 8 into plus 8, minus 64 upon 2 root 29. That is, this is 1116. minus 1116 upon 2 root 29. So that is 116 upon 2 root 29. Now 116, that is 29 into 4 upon 2 root 29. So 2 into 2 4, root 29 into root 29 is 29. So value is 2 root 29. So this is the required distance. Now in this question, find the shortest distance between these two lines. So here equations are in already vector form. But in this form we can't see what is vector A, what is vector B. So let me convert this into simple vector form. So here vector R is, say this is 1i minus 2j plus 3k. Separated terms which are free from variable t, parameter t. Here t is a parameter. So 1i minus 2j minus plus 3k. Now say minus ti, so minus ti, so here I keep plus, here minus I times t, so it is minus ti. Okay, then tj, so I keep here j into t, that is tj, and minus 2tk, minus 2k into t. T is parameter. So terms which are with t, take t common from second bracket, t common. So here t is working like lambda. As for example, vector A plus lambda times vector B. So instead of putting here t, I am putting on left side. See here plus, here I am putting t. T into this vector. T is taken common. Second equation, similarly, separating terms free from, see here s, this is a parameter s, separating terms free from s. So here 1i, so 1i minus 1j plus minus 1k, so 1i minus 1j minus 1k, here main sign is minus, plus, now I am taking s common. S is a parameter like a mu, see lambda, mu, t, s, these symbols can be used, k, m, these alphabets can be used for parameter. So s into, see si, so here si 2sj, so I keep here 2j, so it becomes 2sj, minus 2sk minus 2k, s belongs to R. Check once again, si, so si 2sj minus 2sk minus 2sk. So it is like vector R is vector A plus lambda times vector B. Vector R is A2 plus mu times vector B2. So here the symbols are different. Instead of lambda and mu, t and s are taken. So now here vector A1 is I minus 2j plus 3k. This is vector A1. B1 is minus I plus j minus 2k. A2 is I minus j minus k. Vector B2 is I plus 2j minus 2k. And now you perform ditto procedure. So you can do yourself, finish yourself. Now new result. distance between two parallel lines. Let me take lines R. Vector R is equal to vector A1 plus lambda times vector B, lambda belongs to R, and second line is vector R is vector E2 plus mu times vector B, mu belongs to R. Say in both equations, here parameter is lambda, here parameter is mu. You can also use same symbol lambda, lambda or mu, mu. Wherever we write two equations of lines in the same discussion, equations of two lines, we use this different symbol. Instead of using this different parameter, you can use same also, because it is not a fixed value. Lambda is changing its value, mu is also changing its value. These are parameters. So in both equations, in this theory or in previous discussion, wherever we have discussed two lines, you can use lambda, lambda, or use mu, mu, or use a different symbol lambda, mu. No any discussion will be affected. So let us take different symbol. Here I am taking direction of both lines same. Both lines are in the direction of vector B, because they are parallel lines. So this vector must be same or must have same direction. So these are parallel lines. Here this is first line, this is second line. First line has a point A whose position vector is vector A1. Second line has point B. Let me take this as point A2, this has point A1. Here this point has position vector A2. Suppose this can be expressed like this. Position vector of this point is vector A1, position vector of this point is vector A2. This is origin, and both lines are in the direction of vector B, and we want this distance D. So distance between them is D is equal to modulus of vector B cross vector A2 minus A1 upon magnitude of vector B. So this is the formula. So here we use cross product of vector B and A2 minus A1. In previous discussion we used dot product when finding distance between skew lines. So using this formula we can find distance between two parallel lines. Find the distance between these lines. Say here, observe vector showing direction of lines. Say here, these vectors are same. Direction showing vectors are same. Both lines are parallel to same vector, so these are parallel lines. So given lines are parallel. Here, this is vector A1. 2i minus 3j plus k. Vector vector A2, that is from second equation, I plus j plus k, and vector B is this vector B is I minus 3j minus 4k. Both the lines are in the direction of same vector. So here lines are parallel. So we are using this formula. Now we want cross product of vector B with A2 minus A1. A2 minus A1, vector A2 minus vector A1. So 1 minus 2, that is minus I. 1 minus minus 3, that is plus 4 times J. 1 minus 1, that is 0 times K. So A2 minus A1. Now we take cross product of vector B with A2 minus A1. When taking cross product, in the first row we put I, J, K. Then vector B. Vector B, scalar components are 1, minus 3, minus 4. A2 minus A1, that is minus 1, 4, 0. That is, it is equal to I into 0 minus minus 16, that is 16I, minus J into 0 minus 4, that is minus minus plus 4, plus K into 4 minus 3, that is 1 times K, so it is K cap. It is B cross A2 minus A1. Then say here in this formula we have to take modulus in the numerator. Here modulus, here modulus. This is magnitude. So numerator is magnitude of this cross product. Denominator is modulus of magnitude of vector B. In numerator as well as in denominator, in both the formula, in both the terms, this is a vector, over vector we keep magnitude. This is a vector, over vector we keep magnitude. In previous formula, in numerator there was a dot product, so it was like modulus, and here because numerator and denominator both are vectors, so we use a magnitude. So now taking magnitude of this vector, or directly we can keep in this formula. So required distance D is equal to, formula is magnitude of vector B cross A2 minus A1 upon magnitude of vector B. That is, magnitude of this vector is 16I plus 4J plus K upon magnitude of vector B. Vector B is I minus 3J minus 4K. Numerator and denominator in both the places there is vectors. So these are symbol of a magnitude, not a modulus. So square root of 16 square is 256, 4 square is 16, 1 square is 1 upon square root of 1 square is 1 minus 3 square is 9, 4 square is 16. So it is square root of 256 plus 16, that is 266, 272, 273 upon square root of 26. That is, this is then 273 is 13 into 2, 26, 13 into 21 upon, this is square root of 13 into 2. So it is square root of 21 upon square root of 2. Square root of 21 by 2, that is required distance. Now see, this question is difficult. If L1, M1, N1 and L2, M2, N2 are direction cosines of two mutually perpendicular lines, so that the direction cosines of the line perpendicular to both of these are these three numbers. Say here given that L1 M1 N1 and L2 M2 N2, these are direction cosines of two mutually perpendicular lines. That means because these are direction cosines, so L1 square plus M1 square plus N1 square is 1. This number, second triplet, represents a direction cosines of another line. So for these numbers also, sum of squares of these numbers is also 1. If LMN are direction cosines of a line, then L square plus M square plus N square is always 1. And these are perpendicular lines, mutually perpendicular lines. So therefore, dot product L1 into L2 plus M1 into M2 plus N1 into N2, sum of products of this direction cosines is 0. This is third result. So using this, we want to show that a line which is perpendicular to both has these numbers as direction cosines. So we suppose that let L, M, N be the direction cosines of a line which is perpendicular to given both lines. These are direction cosines of a line which is perpendicular to both lines. So therefore, taking a sum of product of these numbers with these three numbers representing direction cosines of first line, again like a dot product L into L1. So L into L1 plus M into M1, M into M1 plus N into N1 equal to 0, and it is also perpendicular to second line. So L into L2 plus M into M2 plus N into N2 equal to 0. These numbers are direction cosines. So if direction cosines are given or direction ratios are given, then sum of products is 0 if lines are perpendicular. And also because these are direction cosines, sum of squares of these numbers is obviously 1, as it was in equation 1 and 2. So here we have equation 4, equation 5 and equation number 6. Now we want to find the value of LMN. To find LMN, we solve these two equations by cross multiplication method. So we solve equations 4 and 5 using cross multiplication method. Say according to method, here we want L, M, N. Equations are just like linear equations in three variables L, M, N. So here we keep L upon equal to M upon equal to N upon. Now see, L upon, in the denominator of L what we shall keep? Put your hand on first column. Remove column containing L. Now here multiply coefficients M1 into N2. M1 N2 minus N1 M2. M1 N2 minus M2 N1. M1 N2 minus N1 M2 or M2 N1. Then we want value in the denominator of M. So because we want value in the denominator of M in this method, now for second denominator put your hand over second column M. When you want something below M, remove column containing M. Now whatever is visible, so take here number, see, M upon N1 into L2, N1 into L2 minus L1 into N2. Second cross take in opposite direction. See, first of all, when putting this number, what I have done, I have taken cross in this direction. Product of these two numbers minus product of these two numbers means principal diagonal minus secondary diagonal. Now what we will do? Secondary diagonal minus principal diagonal. So N1 into L2, N1 into L2 minus L1 into N2. And for N, put your hand over N, disappear N. Now take cross multiplication, that is L1 into M2, L1 into M2 minus M1 into L2, M1 into L2 or L2 M1. Here L1 L2 we can keep as L2 N2 L1. So say here what we have done, product of these two numbers minus product of these two numbers, 1 2. Then what here we have done, product of these two numbers minus product of these two numbers. Then here product of these two numbers minus product of these two numbers. Say look, in middle denominator we take product of these two numbers, we change direction, minus product of these two numbers. So this we perform in cross multiplication. Then this means, see here we are getting three ratios, equal ratios. This implies, now I am taking square, squaring L square upon M1 N2 minus M2 N1 plus equal to M square upon N1 L2 minus N2 L1 whole square equal to N square upon L1 M2 minus L2 M1 square. Squaring numerator and denominator. This implies L square upon M1 into N2 minus M2 into N1 whole square equal to M square upon N1 L2 minus N2 L1 square equal to N square upon L1 M2 minus L2 M1 square. And continuing this, equal to see each ratio equal to numerator plus numerator plus numerator upon denominator plus denominator plus denominator. So numerator plus numerator plus numerator. Each ratio will have equal to, value equal to numerator plus numerator plus numerator upon denominator plus denominator plus denominator. Now let me say this is equation number 7. Now look, we are going to substitute values in this last ratio. See, L square plus M square plus N square, that we are going to put 1. So this will be 1. And what is denominator? So say denominator can be expressed as, now m1 n2 minus m2 n1 whole square plus n1 l2 minus n2 l1 whole square plus l1 m2 minus l2 m1 whole square. This can be expressed as, it is equal to L1 square plus M1 square plus N1 square into L2 square plus M2 square plus N2 square minus L1 L2 plus M1 M2 plus N1 N2 whole square. So this expression can be expressed by this way. Now putting values, this is equal to, so you have to learn this statement, that this is the substitute for this expression which is in denominator. You can verify this. If you expand this L1 square into L2 square, L1 square M2 square, and few numbers will be eliminated from expansion of this expression, and you will have same. So value of LHS and value of RHS will be same if you verify this result. Now this is, it is 1, this is also 1, minus this is 0, so put here 0. So this is 1. So now I am putting here values. So putting values in equation 7. So we have L square upon M1 minus N2. M1 N2 minus M2 N1 whole square equal to M square upon N1 L2 minus N2 L1 whole square equal to N square upon L1 M2 minus L2 M1 whole square equal to, now this is how much? It is 1. So numerator is 1 and denominator is also 1. So let me say this result is result number 8. So values are from equation 6 and equation 8. So from 6 and 8. So this means, therefore L square equal to M1 minus M1 N2 minus M2 N1 square, comma, M square equal to N1 L2 minus N2 L1 square, comma, N square equal to L1 M2 minus L2 M1 square. Therefore L is equal to m1 n2 minus m2 n1 comma m is equal to n1 l2 minus n2 l1 comma n is equal to L1 M2 minus L2 M1. These are direction cosines of that line. So these are required direction cosines, and that is proved. Say same numbers are derived. So these are direction cosines. M1 N2 minus M2 N1, N1 L2 minus N2 L1, L1 M2 minus L2 M1. Find angle between lines whose direction ratios are given. A, B, C, direction ratios of first line and direction ratios of second line. Now see, we discussed this result, that if A1, B1, C1 and A2, B2, C2 are direction ratios of two lines such that if sum of products A1, A2 plus B1, B2 plus C1, C2 is 0, then angle between them is 90 degree. And by observation it is clear that if you take sum of products of these two triplets, then it will be 0. So say here E into A1 into A2 plus B1 into B2 plus C1 into C2, it is equal to AB minus AC, BC minus AB, CA minus BC. Here this will be cancelled, so it is 0. Therefore angle between lines are perpendicular, 90 degree. In this case, say if A1 upon A2, this was about product, B1 upon B2, C1 upon C2. If numbers ratios are equal, A1 upon A2 plus B1 equal to B1 upon B2 equal to C1 upon C2, then lines are parallel. Then lines are parallel, so what we take, theta equal to 0. So these statements are important. Otherwise, if no such cases occur, then theta can be found by cos theta is modulus of A1 into A2 plus B1 into B2 plus C1 into C2 upon square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square.